Okay, here is video number 2 of the power rule. We talked about just general power rule type problems when you have an exponent, when you have a power and you want to take the derivative of it to end up finding the slope of a function. We use the power rule. Sometimes we don't have exponents. And there's some special cases that I want you to become very fluent in and become very efficient at solving. And I have these 2 cases down here. So think about this. What's the rate of change of the following functions? We have f of x, which is 3x. Now, one thing that you might remember is that this is linear, right? That's the slope. And remember that, right? If it's just, no exponent there, an exponent of 1, that number in front of the x is the slope. So if you think about this function, it's linear, which actually means that its slope or its rate of change is always going to be the same. So no matter what I plug in for x, my slope is always going to be 3. So basically, for any linear function, so if linear, the slope is equal to the derivative. We'll get into some more examples in a second. Actually, I'll just do those right now. So for instance, if I give you, I don't know, h of x equals 5x, that's a linear function. So what's its derivative? Its derivative would be whatever that rate of change is, 5. So basically 5x just turns into 5. What about another one? What about, I don't know, m of x equals negative 2x? Well, that's a linear function. So the derivative is just going to be whatever that slope is. Drop the x and you just have negative 2. So we should be very easily able to identify, okay, if there's an exponent of 1, basically that x just goes away when we take the derivative. And we're just taking the coefficient. That slope becomes the derivative. Well, what if we don't have an exponent at all? Remember what these functions look like. That's linear, but it's a horizontal line. What's the rate of change of any horizontal line? The rate of change is always 0. So anytime I have like a constant function here, our derivative is going to be 0. Doesn't matter what that constant is. Let's say I had given you instead g of x equals 8. Well, that's a constant. That's a horizontal line. So the derivative is 0. And that's true for any function that is a constant. I don't know, negative 100. G prime of x is 0. So a couple of stamps here. A couple of stamps that I want us to know. Number 1, I already wrote down. If it's linear, the slope is equal to the derivative. Basically, the slope is the coefficient. The x disappears. If constant, right? And I'm just going to put in parentheses here, no x. Then the derivative equals 0 always. And this is important because we'll be getting into some problems where I don't really want to use the power rule. You can technically use the power rule for these, but I don't want you to. I want you to just have these down so that you can really quickly go from 3x down to 3, negative 2x down to negative 2, 5x down to 5, 4 to 0, 8 to 0, negative 100 to 0 right away. So now what we're going to do is we're going to practice with some problems that include examples like this. Okay, now we're going to combine basically all of our rules together. So we're going to take the following. Say if f of x equals x to the third minus 2x plus 5, we're going to find f prime. And so what we need to do here is we need to kind of recognize when do we use the power rule and when do we have those shortcuts. Well, I see x to the third here. I see a power, so I'm going to use the power rule. From negative 2x, or yeah, that negative 2x, I'm just going to notice that that's an exponent of 1, so that's linear. And that plus 5, that's a constant. So each one of these, I should be thinking kind of as being a little bit different. So for that first one, when I take f prime, let's use that power. Let's bring the 3 down, and then I'll subtract 1 from that 3 to get 3x squared. Now remember that if it's linear, the slope is that thing, so negative 2. And a constant is going to turn into a slope of 0. So if I want to take the derivative of these three things, we could just take the derivative of them separately and then put them all together at the end. And I get something that looks like 3x squared minus 2. There's my derivative function. So when you're given three terms, just identify basically how to take the derivative of each term independently, take those derivatives independently, and then put those back together. One more example. Let's say if g of x equals negative 2x to the third minus 5x plus 15, we're going to find g prime of negative 2. And then we're going to interpret our answer. Just because we should know what that actually tells us about our function. All right, if I need to find g prime, well, I'm going to identify to myself, when do I need to use the power rule and when do I have other shortcuts? Where I see power rule to start. And then once again, that negative 5x is linear. I'm just going to put L for linear. And then that plus 15, since it doesn't have an exponent, or it doesn't have, sorry, a variable, that's going to be, I'm going to put C for constant. So let's just kind of walk through that. Remember that our power rule, first step is to move that 3 out front. There's already a negative 2 there, so we're going to multiply those two coefficients together. So the 3 comes out front, and that gets multiplied by negative 2. Keep the x, and then I'm going to subtract 1 to give me that negative 6x squared. Let me erase that work there. And then at negative 5x just turns into negative 5, and the plus 15 turns into plus 0. And hopefully you're starting to recognize that we don't need to put plus 0 on there. So I'll get rid of that. And now to find g prime of negative 2, we're just going to now plug that in. And then I get negative 6 times 4 minus 5. And let's see, that's going to give me negative 24 minus 5, which is negative 29. So g prime of negative 2 is equal to negative 29. And I want to interpret, what does that mean? That means g of x, right? The slope of the tangent line at g of x at x equals negative 2 is negative 29. Or what I like to say is g of x has an instantaneous rate of change of negative 29 at what point? X equals negative 2. The rate of change is changing constantly, but at that point, the rate of change is very, very negative. So this is how I would use the power rule. This is how I would use the fact that I have linear and constant terms to take those derivatives very quickly and put all of those things together to continue to find slopes and instant rate of changes of functions or the slope of tangent lines. Go ahead and practice.